So you've probably followed one of those online tutorials, right? Built a simple RAG chatbot in, what, 10 minutes? And then you just had that feeling like, there has to be more to it than this. Well, you're right. Today, we're going way beyond the Hello World examples to see what it really takes to build a production-level RAG system. Okay, let's get into it.
This quote it hits the nail on the head, doesn't it? Those 5-minute tutorials, they're a great starting point, for sure. But the real world is messy. Production pipelines are filled with hidden complexities and critical decisions that those simple guides just gloss over. So let's pull back the curtain and look at what's really going on.
Okay, so first things first. Let's tackle the most common and most flawed idea that everyone has at the beginning.
I mean, it seems obvious, right? You've got this 1,000-page PDF, you want to ask it questions. Why not just, upload the whole thing and let the LLM figure it out? It sounds so simple. But this brute force approach fails, and it fails spectacularly for a few key reasons.
It falls apart in 3 critical ways. First up is the context window. Think of this like the model's short-term memory. LLMs think in tokens, which are kind of like pieces of words. Now, your huge document might be 400,000 tokens long, but even a beast of a model like GPT-4 only has a 128,000 token window. The math just doesn't work. It won't fit. Second, the cost would be insane. You'd be paying for all 400,000 tokens on every single question you ask. And third, and maybe worst of all, are hallucinations. If the LLM can't find the answer in the text, it won't say, "I don't know." It'll just start making stuff up, which is the exact opposite of what we want.
So, if we can't just cram the entire textbook into the LLM's brain, what do? Well, the answer is Retrieval Augmented Generation, or RAG. And honestly, the best way to get it is to think about something we've all experienced, an open book exam. At its heart, RAG is a system that basically gives the LLM a perfect cheat sheet. It doesn't force the model to memorize the entire book. Instead, it teaches it how to be incredibly good at finding the exact right page right when it needs it.
And this is exactly how it works. The user's question, that's the exam question. Then the system instantly scans all your documents to find the most relevant paragraphs. That's it finding the right page in the book. It then gives only those snippets to the LLM. So the model uses its brain, its reasoning ability, combined with the facts from the book to write a perfectly grounded answer. This solves all our problems. It's small enough for the context window, it's super cheap, and it stops hallucinations. So now that we get the what, let's dig into the how. This is where the real engineering starts. All right, the very first choice you, as an engineer, have to make is how to get your data out of its original file, like a PDF, and into a format the system can actually use. This step is called ingestion, and believe me, it is way more important than most people think.
And listen, this is not about finding some magical one-size-fits-all tool. It's about looking at your source documents and making a smart, deliberate choice. Are they clean and simple? Are they messy scans? Are they full of complex tables? This is our first taste of the real engineer's mindset. It's all about mastering the trade-offs.
Check this out. This table really lays out that fundamental trade-off. On one hand, you have a tool like PyMU PDF. For a simple, text-only PDF, this thing is a speed demon. It's unbelievably fast. But if that PDF has scanned images, PyMU PDF is totally blind to the text in them. It just misses it. For that, you need an OCR tool like Tesseract. It's slower, but it can actually read the text inside an image. And then you have the heavy hitters, like Dockling. For those super complex modern reports with intricate tables and charts, it's a powerhouse. It preserves all that precious structure. The catch? It can be 50 times slower. So right away you have a choice to make. Do you need raw speed or do you need deep structural power? Okay, so you've pulled the text out of your documents. What's next? Well, now you have to break it down into those relevant snippets we keep talking about. This is called chunking, and let me be crystal clear, this is arguably the single most important decision you'll make in the entire pipeline.
I am not exaggerating here. The quality of the final answer your user gets is 100% dependent on the quality of your chunks. You retrieve a bad chunk, you're going to get a bad answer. It's that simple. If you get this part wrong, nothing else you do matters. So, how do we get it right?
Well, the 2 basic strategies are fixed-sized and structural. Fixed-size is the brute force method. You just take a sledgehammer and chop your text every 200 words. It's fast, yeah, but it's also kind of dumb. It has zero respect for your content and can slice an important idea right in half, destroying the context.
On the other hand, structural chunking is much smarter. It splits the text along natural boundaries, like paragraphs or headings. This is great for keeping ideas together, but you end up with chunks that are all over the place in size. Some tiny, some way too big.
So, this brings us to a really elegant solution: recursive chunking. It truly is the best of both worlds. It starts by trying to split by a big structure, like a section title. If any of those chunks are still too big, it recursively splits them again by the next level down. So, paragraphs. Still too big? It goes down to sentences. It's this beautiful process that respects the document's logic while also keeping every chunk a nice, manageable size.
And you can see just how effective it is right here on this chart. Look at this. Fixed size chunking. Sure, it gives you high consistency, but the chunks themselves are meaningless. Structural chunking? It respects the content, but its consistency is low. The sizes are all over the map. But recursive chunking? It nails both. You get high consistency and you preserve that all-important semantic meaning. It's the intelligent compromise that just works.
So, we've walked through ingestion tools and chunking strategies. But the real lesson here isn't about memorizing a list of libraries. It's about stepping back and adopting a certain mindset about how you build these systems.
And this is the core idea. Building a production-grade RAG system isn't about knowing the documentation for some framework by heart. It's about developing the engineering intuition to look at a problem, analyze it from first principles, and make deliberate, reasoned choices about the trade-offs you're making at every single step.
And these are the principles that should guide you. Always start by deeply understanding your data. Then, pick your tools based on that data's specific needs, not what's popular. Choose a chunking strategy that honors the logic and flow of your content, and above all else, always ask why before you write a single line of code. It's about thinking in principles, not just plugging in frameworks.
So, I'll leave you with this question. The next time you're tasked with making knowledge accessible, are you just going to import a library and hope for the best? Or are you going to embrace the engineer's mindset, ask the hard questions first, and build something that is truly robust and powerful? The choice is yours.